Today class we discuss templates. Today class we discuss template. A template is a new concept in C++. Template to define generic classes and functions. Template to define generic classes and functions. Okay. First, what is mean by generic? Generic or generic? Okay, generic medicine. அப்படின்னு சொல்றாங்க. Generic store, generic medicine. Like what is mean by generic? Okay, generic functions or generic classes. What is mean by generic? Suppose we have general medicine or generic medicine அப்படின்னு சொல்லுவோம். Okay, what is the purpose that medicines are used? That medicine is used for more than one diseases. Suppose example, one tablet name is Calpol. Okay, the Calpol is used for cold purpose and also fever. At the same time, the paracetamol. The paracetamol is generic medicine. The medicine is used for more than one purpose. Okay, so here at the same time general store, generic stores. The stores is used for at the same time more than one things placed in the common place. So that is called generic store. The generic store is not sale particular product. So all product sell the particular generic store. So you know what is mean by generic. Generic is a common term. So used more than one purpose. Okay, so for the same constraint here also using. So the generic class and the functions provide support for generic programming. Provide support for generic programming. So generic programming is nothing but the program used to solve more than one operation. Or the program perform more than one operation. So that is called generic programming. Okay, right. The generic programming is an approach where generic data type are used as a parameter in algorithm. Okay, the generic programming is hold the generic data type. The generic data type used in the algorithms. Okay, right. It's work with variety of data type and data structures. Okay, so simultaneously work with variety of data types and data structures. We already know what is mean by data types. Data types is an example for integer, character, float. Okay, so the data structures is called stack, linear, cube. So here we are using generic data type to perform the generic programming. Okay, right. Next, it support all kind of data types. You already told it support all kind of data types. So here we creating only one functions or only one classes. That classes used all kind of data types like integer, float, and double characters. Okay. So template is defined with a parameter. Template is defined with a parameter that would be replaced by a specific data type. That would be replaced by a specific data type at the time of actual one of the class or functions. Okay, so template is defined the parameter. That parameter is replaced the actual data type at the time of program execution. So this is called generic programming. Okay, so the parameter is replaced the template parameters. So the template parameters is replaced by actual parameter type and values. So we pass the parameter to that generic class or generic functions. So it is called parameterized class or function. It's called the parameterized class or functions. So here the template is classified in two different categories. One is called function template. Function template. The function template is called generic function. And the class template is called generic class. So template is classified and template is used in two ways. One is called the function template or generic functions. Another one is called the class template or generic classes. So this is the some basic introduction about the template. Now you all understand what is meant by generic programming. So generic programming, you write any one of the function or any one of the classes. That classes is used variety of data type at the time of actual execution. Suppose I creating one function. That function is a generic function. That function is simultaneously work for integer data types and also is work for character or double or float, anything. So based upon the passing the parameter, the generic functions is work together. Discuss function template. So the function template used to create a family of functions with a different argument or parameter. So the function template is used to create the family of functions with a different argument and parameters. So you already know the one concept is called function overloading. What is mean by function overloading? Function overloading is nothing but the same function use more than one purpose with using of different argument or different parameters. Okay, so function overloading is nothing but a same type or same name, same function name using the same name. Okay, it acts as different in different situations. Okay, how to create the different situations? So number of argument passed into that function, or the number of order of the argument passed into that function, and the type of variable is different to pass into the functions. So through these three way to achieve the function overloading. Okay, so here first we know what is the concept of a function template. Function template are generic functions. So generic function is nothing but the same. One function using the more than one purpose. One function using the more than one purpose. So it's called to create a family of functions with using of different parameter or different argument. First, we say what is a syntax? Syntax of template. Syntax of template. Okay, so we first template class T. Template class T. Second, the return type function name, then function name argument of type T. Argument of type T. So here we are using the class T. So the class T is passing the argument of this function. Next, this is a function body of function. Next, using type T whenever it's appropriate places. Whenever use appropriate places. So this is the syntax of function template. So template class T. This is a template class T. This is called angle bracket. Okay, angle bracket. So template angle bracket class T. Here we are using any one of the variable name. Suppose in some books follow the capital T. So now here following the small t. Suppose you want any one of the variable, you using that variable. Okay, right? So return the function return type. That is the return type. Function name. Argument of type T. Okay, this is the body of the template function or the function template. So body of the functions using the type T inside wherever or whenever it's used the appropriate place we are using the type T functions. Okay, right. Next the function overloading. Next we are going to see the concept of function overloading. Defaultly we are using in object oriented programming with using of one example. Okay. So example, include iostream.h, include dot h. Okay, the first function sum of int a comma int b. So you make the return type a plus b. So second float sum of float x float y. So it's return x plus y. Okay, write the main function main. So here CLR is here, clear the screen. Next you first call the integer function. So call integer function. So Cout sum of 10 comma 20. Then you call the float function. Cout sum of 1.2 comma 2.2. Then get. Okay, this is the example for function overloading. Okay, here we are using the function name is sum. So sum is common to two functions, but here you are passing the parameter argument. So here you are passing two integer variable. Here you are passing the two float variable. After the function is written one integer variable. After the function is written one float variable. Okay, so this is called the function overloading. So the same name of function using in different situation is called the function overloading. Okay, right. Here, clear the screen. First you call the integer function. So you passing the argument, two integer argument 10 comma 20. So the function call. So this function is called this. Okay. Second, you are getting the output 10 plus 20, 30. Okay, right. Second, the function is called float. So first output is 30. Second, the function is called float 1.2, 2.2. Then the function, this function is automatically invoked. So because you are passing the two floating point, here also you have the two floating point. Here you are using the two argument. Here also using the two argument. So you exactly match this. So the float functions, the float sum will be executed. So 1.2, 2.2, you are getting the answer for 3.4. Okay. So this is the first function output. This is the second function output. So we are overloading a function. Overloading the function name sum. Okay. Overloading the function name sum. Right. Now this function, two function call here we are using, two function definition here we are using, but no reduce the code. No, we are not perform the reducing the code, but with using a function template, how to reduce the code. Okay, now we are going to discuss the function template, how to reduce the function code with using a function template. With using a function template. Okay, right. Example. Function template. Example. Function template. Okay, right. Same. Include iostream.h. Include codio.h. Codio.h. Okay, you are creating the template function. Template class T. Template class T. Okay. So here is the syntax of the template return type. So here we are using the template return. Okay, class template T return type. You write the sum. Sum is the function. Okay, you passing the argument, two argument. So T comma A, T B. Is a two argument. Here same is written A plus B. Written A plus B. So here this is called function template. This is called a function template. So how to create the function template? template, angle bracket, class, T. Okay, right? This is a T. T is a return type. T. Sum. Sum is a function name. So this is a T. T is an argument. First argument T A. Second argument T B. Okay. The finally is written A plus B. Okay. A plus B. The A plus B is also T. A plus B is also T. Right. Now we define the void main. Void main. Now we define the void main. CLR, SCR. Okay. First, suppose now we are passing the integer value to the template function. So cout call integer. So that is called cout sum of 10, 20. Sum of 10, 20. So 10 is one of the integer value. 20 is one of the integer value. So here the integer value is passing the class T. So T is the integer. So return type. So T is the integer. So the 10 T is the integer A. The 10 assign A. 20 assign B. So 10, 20 is both are integer. So the return value is also integer. Now the function template, the class T is taking the integer data type. So because you are passing the two integer value is assigned here, A and the B. So is finally you add the sum. The final result is written to T. The T will be presented. So output to the same output. Okay. Suppose now we are using the float. Call float. So cout sum of 1.2, 2.2. Get sum of 1.2, 2.2. Okay, right. 1.2, 2.2. 1.2 is also a float. 2.2 is a float. So now the class T is a float. So float 1.2 value is assigned A. Float 1.2 value is assigned B. Okay. So the class T is act as a float data type. So return type is also float because 1.2 plus 2.2 is a 3.4 is also a float value. 2.4 is also a float value. So the float value is return T. So here the T is a float data type. So here we are using the only one function definition, but here we are using the two function call. Suppose first you are using integer function, so integer template will be called. Second you are using float function, the float template function we will call. The function definition is same, but here we are using the more than one purpose. One purpose for integer value, another purpose for float value. So this is called function template. Here in previous example we are using the two function definition, two function call. Here we are using the only one function definition, but the one function definition is simultaneously work two function calls. Suppose you are passing the integer, the function template is act as the integer value. Float, the function template function is act as a float. So this concept is called the template function or the generic function. In previous section, function template, we are using the one data type to the function template. Example, T sum of TA, TB. So here template class T. So here we are using only one data type. Suppose you are passing integer, so the t acts as a integer data type. Suppose you are passing float, the t is act as a float data type. Okay, so one common data type to passing this argument. Suppose I want pass different data type. Here integer replace that I pass integer float or float integer or integer. Okay. So suppose a mixed data type pass to that function at the time how to define the function template. At the time how to define the function template for mixing data type pass to the argument for the function template. Okay, mixed data type or mixed argument passed to the function data type. Okay, to example that. Example. Example 2, to pass different data type to the function template. To pass different data type to the function template. So, has include iostream.h include conio.h. Okay, so I create the function template class t1 comma class t2 function template class t1 and t2. Okay, again you have the return type. Return type. So return type, suppose you passing integer, so return type is integer. Suppose you passing float, is the return type is float. Now, we passed two different data type. So here integer, float. T1 is a integer, T2 is a float. Now the return type is large size of data type act as a return type. Suppose here integer is a 2 bytes, float is a 4 bytes occupying the memory. Suppose here we are using return type as a float because float data type occupy 4 bytes. Integer data type occupy 2 bytes. Which one is large? Which one is biggest one? So float is the biggest compared to the integer. So here you are using the data type float. Okay. So then sum of. So here T1 A, T2 B. T1 A, D2 B. So here return A plus B, that's all. Okay, so here you are passing the two different arguments. So one argument is an integer, second argument is a float, or first argument is a float, second argument is an integer, or 1 and 2 argument is an integer, 1 and 2 argument is a float. The four possible ways the function definition is invoked. Okay, so here using the void main. So CLR, SCR. So first C out using two integer. Two integer. So C out sum of 10, 20. Sum of 10, 20. So sum of 10, 20. So 10 is integer, 20 is integer. So here T1 is a 10 integer, T2 is also a integer. So T1A is a 10, T2B is a 10. Both are integers. So you calling that integer. So return type float. So integer is return type float is occupying because is automatically type conversion. So integer is converted to float, but the float is not converted to integer because the floating point value is truncated. So here we are using that 30. So here you are calling that 30.0. You are getting that answer. Okay. So now you are passing two float value. Cout to float. To float. Cout sum of 1.2 comma 2.2. Sum of 1.2 comma 2.2. So here T1 is also float, T2 is also a float. So T1A is a 1.2, T2B is a 2.2. So is add together. So this is called 3.4. 3.4 is a float. So is returned the value of 3.4. Okay. So second, Cout one integer, one float. One integer, one float. Sum of 10 comma 1.2. 10 comma 1.2. So here T1 is a integer, T2 is a float. Okay. So T1A, A is a integer 10, B is a float 1.2. So final is added 11.2. 11.2 is a float. We are getting the answer 11.2. Okay. So another Cout. What is that? One float, one integer. So Cout sum of 1.2 comma 20. So here the first argument is a float. Second argument is an integer. So here A is a float 1.2, B is a integer 20. So final is a 21.2, is return value is also a float. So 21.2. Okay. So get. Here we are using only one function template. The function template used in 4 function call. Used in 4 function call. Used in 4 function call. So 4 function call using the same function template. So this is called the generic function or generic programming or function generic function template. So here we are using the function overloading. So here we need 4 function call but only one function definition. But without template we need 4 function call, 4 function definition. So simultaneously the function template is reducing the program size and also it producing the generic programming. It producing the generic function or the generic programming. One common functions use more than one function call. So that there is a concept of function template. The third example of function template. Third example of function template. Example 3. Create a function template passing array as a function argument. Creating a function template passing array as a function argument. Suppose I find out the sum of array. I find out the sum of item present in the array. Okay. So that array is an integer array or floating array. The array size is different. So here we are passing the 2 arguments into the function template. One argument is a array type. Another argument is a constant, that is meant by integer type. Okay. So one argument is a array type. Another argument is a integer type. So this is the third example is used to create a function template to passing array as a function argument. Array as a function argument. That array may be a integer array or float array. But we're creating only one template functions to perform both integer array and float array. Okay, right. So here hash include iostream dot h, then hash include conio dot h. So two header file is ordered. So next you creating the function template class T, because you passing either one integer type or float type. So only one class T is a present. Okay. So is a function return type is a T. Return type is a T. So function name is also sum. Then you pass T array type. Then you pass T array type. This array may be a integer or this array may be a float. Then another parameter is called integer size. Another parameter is called integer size. Size is nothing but a size of the array. Size is nothing but a size of the array. Okay. So then you put the sum. Sum equal to, you put sum, that is meant by S. S equal to 0. S is what type? Is it integer type or float type? We don't know. So you put T. Suppose what is meant by T? You passing an integer, so T everything is integer. You passing a float, T everything is a float. Okay, we don't know what data type you pass to the function, maybe integer or float. So it's commonly we are using the template class T. Okay, right. So next for int I equal to 0, I less than size I plus plus. I less than size I plus plus. So then S equal to S plus, S equal to S plus A of I. S equal to S plus A of I. Finally is written S. Finally is written S. Okay. So you already know S equal to 0. So I equal to 0 to what are the size is passing in this? Okay, size less than 0. So S equal to S plus A of I. So read one by one. The array element read one by one. Then array element store add to the S. Final result is stored in S. That return the final value. Return the final value. Okay, right. Now define the void main. Void main. You define the void main. So you are creating the two arrays. One is called integer array. Integer array int x of 5 equal to 10, 20, 30, 40, 50. So this is an integer array. Then you are creating the float array. Float y of 3 equal to 1.1, 2.2, 3.3. This is a float array. Okay. You perform the sum operations. Okay. So we put CLR, SCR. Okay. C out. What is that? Sum of, you passing the first array is x, comma, size is 5. Array is x. X is an integer array. X is an integer array. So size is 5. Okay. So x is an integer array. So here t is an integer. So integer int a of 0. You already know int size. So int s. Up to what is that? 10 plus 20 plus 30 plus 40 plus 50. So 30, 60, 100, 150. Okay. So 150 will be stored in this. Okay. So here you pausing the integer array. The integer array size is 5. Okay. So when you call this function template, everything is act as a integer. Okay. So suppose I call float. C out. Sum of float array is y. Size is 3. float array is y, size is 3. So now the function is called, what is the size? Y? Y is the float. So t is replaced by float. So float, sum, float a of 0 in size, float s of 0. Float s of 0, then everything. So what is the final answer is 1.2, 2.2, 3.3. 1.2, 1.2, 3, 1.1, 2.2, 3.3. So what is that? It is meant by 6. So the final answer is 6.6. Okay. So everything is completed. So you put H. That's all. Okay. So here this function template is used. You passing an array as a function argument. Array as a function argument. But only one function template is created. The function template is used both integer and the float. Suppose I want to pass integer array, so the function template acts as the integer function template. So you pass float. Also at the time the function template acts as a function, that is a float function template. So only one function definition, that is a template function definition, is used for both concepts. So this is the advantage of template function as the generic function. Okay, next example. The overloading the function template. Overloading the function template. You already know what is mean by overloading of the function. What is mean by overloading of the function? Function overloading. Function overloading you already know. Function overloading is nothing but the function name used for more than one purpose. The function is used for more than one purpose. So function overloading how to achieve? So number of argument passing. Okay, number of argument passing. At the order of argument passing. Then data type. So based upon this situations, the function act in different. Okay. So suppose we creating the function, the overload function template. Overload function template. So this is the example for overload function template. How to create the overload function template. Overloading the function template. Okay. Right. Listen. Include iostream.h, then conio.h. Okay, you must add it. Has include iostream.h, has include conio.h. Okay, now we are creating the template overload. Template class T. Templates class T. So is the T is the return type. So what is that? Sum of TA comma TB. So is the return A plus B. Okay. So here you are passing the two argument. The two argument may be integer or float. Okay. Then you can create another, what is that? Template class T, template class T. Here T, sum of TA comma TB comma TC. So is written of, that is A plus B plus C. It's written of A plus B plus C. Here we are using the two argument. Here we are using the three argument. Suppose you passing this two argument is an integer. This function is invoked. Suppose you passing the two argument is a float, this function is invoked. Suppose you passing three integer or three float, at the time this function is invoked. Okay, because the number of parameter should match. The number of parameter should match. So three type of parameter and also three type of parameter of the same type. Okay, right? You write the void main. Void main. Okay, void main. First, cout sum of 10, 20. Okay, suppose you find out sum of 10, 20. So two integer. At the same time, two number of parameter. So first function call, this function template is invoked. Okay. So second function call, cout sum of 1.2, 2.2. So here two function, two parameter. The two parameter is a float type. So again this function is invoked. Okay. So next, cout sum of 10, 20, 30. 10, 20, 30. Okay. So number of argument is passed, 3 argument. So here only have the 2 argument, but here have 3 argument. So this function is perfectly matched to this function call. Okay. So 3 integer value is passed, 1, 2, 3 integer value. So at the time this function call, this function definition will be invoked. So next, cout sum of 1.2, 2.2, 3.2. 1.2, 2.2, 3.2. So how many parameters pass? 1, 2, 3. 1, 2, 3. Is a floating type, so float. Only one. Float. So float A, float B, float C. So 1.2, 2.2, 3.2. Finally is written float. So this function call, this template function is invoked. So now here we define the two function template, but the two function template is called with using of 4 variety of function calls. We call using of 4 variety of functions call. So this concept is called function overloaded. How to achieve the function overloaded? The function overloading is nothing but a same function name using in different situation. How to make the different situation? You already know. You passing the parameter data types, and you passing the number of parameter, and also order of parameter passing to that function. So this way the function overloading template is achieved. Okay, using of these 4 examples, I think everybody will understand what is the template functions, what is the generic programming, and how to use the template function with a single data type, and how to the template function use combined data type, and number of argument is varying. Then suppose I want to passing the arrays argument. So everything is discussed with using of 3-4 examples. The student is understanding well. Okay. So after completing this, we put the get function. So finally, you close the program. Okay. So this is called the template function overloading. Okay. Next, we discuss about class template. Okay, like function template, we have the another concept, another way of template creation is called class template. Now we are going to discuss class template. Okay, so class template. So class template or generic class. Okay. It is also called generic class or class template. So declare the class in template or generic class. That class data type is used integer or float or any one of the data types. So we are creating the common class or the generic class. Okay, that class is used for what kind of data type is created at the time of function invoke a class used. Okay, at the time of object creation. That purpose, the class is automatically converted. Okay. So suppose I want to creating the integer object, so the class is act as a integer variable. Okay. At the same time, suppose I creating the float object, at the time the generic class is act as a float. Okay. So we go see one example to discuss the how to create the class template. Okay. Right. Class template. Example. Class template, you must include iostream.h and conio.h. So two header file, iostream.h and conio.h. So first creating the template like that, class T. Okay, template like that, class T. Okay, is a common how to create the class? Class name, other class and class name. So here test is the class name. Test is the class name. Okay. So the first section is called the variable declaration. First section is called variable declaration. We don't know what type of variable here is created. Okay. So for the purpose, we are using the common name T A comma B. Okay, T A comma B. Suppose we are creating the integer, so here A and B is an integer variable. Suppose we are creating the float, the A and B is a float. Okay, we don't know what kind of data type is declared in main functions. So we put the common name T of I. Another is public section. Public section, we are creating the data, that is mean by function, member function. So void get data. Void get data. The void get data is used for the getting the variable C in A, B. C in A, B. So in previous programming, here we are using the integer value A and B, enter into the float value A and B. But here we don't give the cout statement because we don't know what type of parameter pass or what type of values we getting using the get function. So simply we are using the C in A, B. Okay. Then another function is called sum. Another function is called sum. Suppose you are getting a value through get data A and B, then sum of that value A and B and finally is written. Okay. So you should return. So another member function T, that function name is sum. Sum. Okay. So right. So void get data is one of the member function of test class. Another one is called T sum. T sum is one of the member function of the test class. Okay. Here we already defined the function. This is called the defining the function. But here is only declare the function. Declaration. Okay. It's not definition. It's only declaration. So we want to define this function outside the class. We define this function outside the class because you already know how to define the function inside the class. Okay, same like your ordinary class will be created, but we define the function outside the class is slightly modified. So how to define the function outside the class? Okay, so we define the function outside the class. Here also you are using the template class T. Template class T. Is a return type is a T. Function name is test scope resolution operator. You already know return type function name, return type, class name, scope resolution operator, then function. Okay, this is a ordinary member function outside declaration. But here in template, we put this function is belongs to in what? The function is belongs to this class template. So put angle bracket T in between the test and the scope resolution operator. So remaining everything is same. So return type we don't know, you put the T. Okay, this is called the class name. So scope resolution of the function name. These are the syntax of outside the member function definition. But we include the class template. Okay, it's a class template in between the test and the scope resolution operator. Then you like this, return A plus B. Return A plus B. So this is called outside function definition. Outside function definition. So you already know how to define the function inside as it is. Suppose I want to define function, member function outside the class using in this format. Okay, right. So we go to void main. Void main. So CLR SCR. Okay, creating the object test T1, test T2. Okay, you creating the object test T1 and T2. So based upon this object creation, the class will be work is an integer type or float type. Okay, suppose I give here int float. So the T1 object used integer data type, the T2 object is used float data type. Okay, so this only difference. Okay, so you creating the common class, but the common class using in different manner. How it's using in different manner to creating the object. So this is called integer type object. This is called the float type object. Now we getting the value. Okay, so here cout integer data use பண்ணும்போது just integer. Okay, so cout just printing purpose. So now you get T1 dot get data. T1 dot get data. Now D1 dot get data. The D1 dot get data now is everything is integer. So getting the integer value of what is that? A and B. Getting the integer value of A and B and perform cout T1 dot what is that? Sum. T1 dot sum. Okay, T1 dot sum is only integer value. You give the integer value is what is that? 20, 30. So answer is 50. Okay. Then using the float, cout float. So here you are using the T2 get data. Okay, T2 is a float type. So this is a float. Everything is float. Okay. So you getting the value of this. So that is the value of this 1.2, 2.2. So you're getting the answer is 3.4. Okay, so T2 dot cout T2 dot sum. T2 dot sum. Finally, get close the main function. Okay, so this is called the class template. So we are using the common class. The common class is using integer and the float purpose simultaneously. Okay, so this is a generic class. Okay, now you understand what is meant by function template and what is meant by class template. So what purpose the function template and class template are used in effective manner. So it is used reducing the coding. Okay, this is the main purpose. It is used to reducing the coding.